So signals have been introduced in Angular as a developer preview in version 16. At the time of this video, we are at 17.1, and we have already exclusive features that come with signals, which is the local change detection and the signal inputs. With 17, the signal function, the computed function, both got stable, and the effect function is still in the developer preview. But nevertheless, we have already some advantages that we can gain from them, and it's time to think about integrating into our applications. And it also means we need to be able to test them. What do we have to be aware of? Are there some things that we have to be very careful about? So these are the things that I want to discuss here in this video. Okay, so this is the component that we want to test. It's a basket component. We have here two different products. And as you can see, it also comes with the total price. Now, if I click on add or on decrement, increase or decrement, then we see that the total is changed here as well. Another way how the implementation works is that we have here our basket component. So that's this one, quite a lot of template there. But in the end, in the TypeScript class, we have here the products, which is a signal containing all the products which we have seen. We also have here a sync service. That's a service which should do some kind of synchronization stuff as soon as the products change. And that's why we have here an effect. So every time those products change, the sync service is executed with the sync method. And then we have here our total price. The total price just calculates the total price, and it is implemented in the form of a computed, as we see here. And at the very end, of course, we also have our decrease, our increase methods. And what they do is that they call products update, and then they just increase the amount of the particular product or decrease it. Now I want to test this. So this is now all based on signals. And since this is a component, we will start, or we will do a simple component test. That means I need to say testbed, configure testing module. And in there, I am importing my basket component because it is a standalone component. And then I say create component, basket component again, and I store the result in the fixture. So I have now my component fixture. What we usually always have to do in the very beginning, when a component has been created, we need to instantiate it. We need to make sure that all the lifecycle hooks start and that stuff. So that's why we call here fixture detect changes. And now we can already verify if the total price is calculated in the right way. So since this is a component here, I'm not going to directly access the component instance, the TypeScript class, but I'm really interacting with the component via the DOM, which means I will click on the button. I will not call the event listener method, and I will also not verify against the property, against the signal property, but against those things which are rendered in the DOM. And maybe we start with that one first. So I say I need to now fetch somewhere the total price from the DOM. So I use here my fixture again. I say debug element, I say query. With query, I have the possibility to use by CSS. It means I can select something with the help of the CSS selectors. And then, because my total price has attached a data test ID attribute, which makes it uniquely to select, I can say, yeah, there is a data test ID attribute which has the value total. And this, I want to then fetch the native element, and I want to store this into the variable called total. And this is a HTML div element. And if everything works, I can now verify if my total, the DOM element, if I'm able to type it, has a text content with the value 18. It's a string. It's of course not a number, it's a string. We are here accessing the HTML. So I rerun my test. Need to rerun the write test, and we see it is working. And the next step now is that I increment the first product. So I need to click on the button. So let's quickly check out what kind of button or how we can access this button. So we have here the button increase, and that's the data test ID. So again, I can use the same selector approach that I've used before. So I say, yeah, this is the same fixture debug element. This time it's button increase. And yeah, I click directly on the native element. I don't need to store it into a variable or something. If that has been done, then internally the total price should be recalculated, which means I need to trigger now the change detection so that my DOM gets updated with the current value. That's why I say here, detect changes. And then I can copy my assertion again, and I leave it with 18 because I would expect that it's now 21. The coffee costs €3 and it should be 21, which means that the test now is supposed to fail. Yeah, which it does. So it's 21. So we see in comparison to a component test without any signals, there's not that much difference. What's missing though is the effect. So that the total price is computed and the effect is still missing. We see already the effect in the console log here because it is also executed 2 times and it just prints the product to our log. So what I want to do now is that I want to verify that the effect function or the function inside of the effect is executed 2 times. How do I do that? I need to get access to this sync service that we've created. So I say here testbed inject sync service. The sync service is provided in root. So I just can say inject and I will get the original right away. So I'm going to store this here. So sync service, and I will now create a spy on it because otherwise I can't know how often it was executed. So I say I have my spy, and that spy on the sync service, and I say whenever the sync method is called, I want this information to be stored in the spy variable there. Good. So now I need to find out those places in my code when the spy was executed. We can already say after the first change detection, the effect is already executed for the first time. Again, I will make it a little bit different. I will let the test fail first to verify that the test is really doing what it is supposed to do. So I say here, before detect changes, spy to have been called 1 time. And this should now fail because the spy wasn't called. And it fails, right? So called 0 times. Now I'm moving it after the change detection. Let's rerun it. And the test is working. Successful. So that means that with the change detection, the effect, and not just the computed, but also the effect, is also executed. And this is already very important to understand what happens here. Because the effect, and the same in a way is true for the computed, but especially for the effect. The effect has to be triggered by somebody. And at the moment in Angular, because we don't have any signal components yet, that's still the change detection. So every time the change detection is executed, it also goes to the effect and says, under the condition that you are dirty, please rerun your inner function. What does mean dirty? Dirty means that the effect is aware of all its depending signals, and it knows at any point in time if one of these dependent signals have been changed. But it's not executing the side effect right away. It really waits that somebody comes to it in a way and says, yeah, now it's time, rerun if you are dirty. And in our case, again, that's the change detection. That has a consequence. The consequence is, if I'm running now the change detection a second time against a clean and not dirty effect, then it will not have any effect. So the function internally will not be executed. So if I would now think, well, detect changes is running the effect a second time, I'm wrong. So if I say here 2 and I rerun the test, we will see that the test is going to fail because it was just executed 1 time. That is important to understand and to remember. So when isn't executed a second time? Well, when the change detection runs, yeah, that's still necessary, but also when the effect became dirty. And that's when the products have changed, which means after I have clicked on this native element there. And again, I could now say, okay, I put it here right after the click. Should happen synchronously. So the effect execution should happen right after the change to the signal happened. But again, that's not the case. Somebody needs to trigger the effect. The effect, of course, knows right now that the products have been changed, but it's still waiting that somebody triggers it. So I need to move it right here. Now if I rerun it, the test is working. Good. So there are some things you have to remember, but in the end, if you just run detect changes as you would normally run it, then you don't really face any difficulties when it comes to the effect and to the computed. As long as you're working directly with the DOM, as long as you have change detection, which is of course something you don't have if you test a service, which is what we are going to do now. So I have now the idea that I say, yeah, the component, the basket component here, that's quite huge. So it has already quite a lot of template and also a little bit of logic. I want to move the logic into a separate service. So I'm going to take all of that code. I'm going to copy it or cut it out. We have here already our basket service. I put it in there. And so what our component has to do now is that it only needs to inject this basket service. So it says here inject basket service. And then of course we need to expose the properties of the basket service now for the template. So I say, well, there are the products and that's the basket service. So I access it like this. Then we have also our total price. I also provide it like this. And then I need to provide the two functions for increase and decrease the amount of products. So I say here increase function is a number and please call basket service increase ID. And then we also have here decrease where I am doing the opposite. Good. But that's the refactoring, and one of the nice side effects when you have tests is that you can now check if the basket component is still working as it is supposed to be. So I need to rerun the test and we see it's green. So didn't introduce any bugs, basket component is still working. But now I say, okay, basket component is one thing, I want to test only the basket component, the basket service. So I go back into my test and I say it should test the basket service. Now, because I don't work now against the component, I don't need to say create component, I will also not get my component fixture, I will also therefore not get access to change detection, so I need to find another way. But in order to get access to the basket service, it's very easy. I just have to say testbed inject basket service. Basket service is provided in root. It has just one dependency to the sync service, which is also provided in root. So I don't need to do anything else except saying here inject, and I'm getting access to the original services. So basket service here, and then basket service, sync service there. So yeah, now let's start with the total price first. The easy one, the computed. When the basket service is instantiated, that means that obviously the total price also needs to have already a value. So that means if I say here expect basket service and I access the total price and I access it by requesting the current value, then I can say, well, it should be 18. Yeah. Let's say 21 because I want to see the test failing. So I rerun it. And the test is failing because it's 18. Great. So I say here 18. Good. Now I say I want to increase it. So I say basket service, increase 1. And again, I hope that the test is not failing because it should be 21 and not 18. Let's rerun it. Yeah, fine. It's 21. Good. Nothing really spectacular, nothing really new. That just works. Again, why is there something we have to be aware of? Kind of. As I said, or as explained before, the computed works in the same way as the effect. It needs to be triggered by somebody, and otherwise, I mean, we can't really say it's not running because there is no side effect. So in general, when it comes to computed signals, it's very easy to test them because you just need to call them and you get the current value. But for signals, it's different. So if, for the effect, it's different. Because if I now come up here with a SPI again, and if I say SPI on the sync service, and I'm now going to the sync method again, and I say, well, let's start, or let's go to the very end. And we know that since the computed was also executed, well, the effect should also have been executed. So my SPI should have been called 2 times by now. Let's see. No, wasn't run at all. Not good. So the effect was never executed. And again, that's the problem here, because there is no change detection. There is no one there which triggers it. Unfortunately, we also don't have the possibility, like with computed, that we can access that effect on our own. There is no possibility to call an effect as it is with computed. So it's not very easy, but there is of course a solution, because otherwise I wouldn't have done the video. And the solution here is flush effects. So that's a test, that's a method which is provided to you via the test bed, and that is doing exactly what the change detection is doing for the effect. Namely, it says if the effect is dirty, run it. But of course I need to know when to call this command. I can't just call it somewhere. The effect needs to be dirty. So I can start from the very beginning. So I say here, not flush effects. That's the name of the command. And since total price was had already the value 18, with flush effects, the same is true also for the effect. It is also dirty in the very beginning. So if I say here flush, it should have been executed 1 time. Well, I can rerun it. Test working. And again, the same rules that we have seen before with the change detection apply here as well. It needs to be a dirty effect. Just running flush effect is not enough. So if I say here again flush effect a second time, and I would expect that now the SPI has also been executed a second time, that's not the case. It's just called 1 time. Good, so I need to place the testbed flush effects for the second time where it belongs to, and that's right after the increase, after the product's signal was changed. And then it will work. So if I then move the to have been called here, also after the flush effects, we will see that now the test is working as well. So summary, as long as we are writing tests that interact with the DOM, where change detection is included, we don't see any real difference when it comes to signals, or maybe to be more precise, with effects. But if we are testing services where we don't have a change detection, then we need to flush the effects manually, and that's via the flush effects command. And we also have to remember, flush effects only works if the effect is dirty. Otherwise it has no effect. And by the way, you can also use the flush effect in the DOM-based so-called tests as well. That would also work here instead of running fixture detect changes. But yeah, I mean, if you have already a DOM-based test where you have already to run the change detection, why do you actually want to use flush effects? That doesn't make sense. So that was it already. By the way, my name is Rainer Hanekamp. I'm trainer and consultant at Angular Architects. And if you're interested, if you want to learn more about testing in Angular, then maybe our testing workshop is exactly what you're looking for. I would say thank you very much for watching. If you like this video, please give it a like. Also subscribe to my channel. And of course, if you have any questions, then just ask. Thanks again and see you in the next video. Goodbye.